The second part of today's lesson deals with why we might write an equation for some information that's given to us. Let's take a look at two examples here. We have an oil tank is filled at a constant rate. Now, typically constant rate, when you see that word, it's a key word there telling us that we're going to be dealing with a linear equation. And so linear, when we think of linear, we're thinking of an equation in this form, y equals mx plus b. So constant rate is a key term that you're going to want to remember, especially when we get to writing equations that are not linear. That might be quadratic or maybe a cubic equation. So we always have to look for key words, and that's one of those. Key phrase in that case. Well, anyhow, the oil tank is filled at a constant rate, so we know it's a linear equation. The depth of oil is a function of the number of minutes. This is another key bit of information that tells us what y is and what x is. So typically when we're solving one of these, what we have is this. We've got a dependent event. So a dependent. So dependent means, well, it depends on something. Well, a dependent event equals some sort of constant. And so I'll use k for constant in this case. So some sort of constant like k, and then it's multiplied by an independent event. And so we have our independent event multiplied by some sort of constant. Constant's like our slope. And so this is the rate of change. Rate of change. And we think of this as just being our slope. So I could have even used m for that instead. Anyhow, when we look at it, the depth of oil is a function of the number of minutes. Well, what's dependent is this, the depth of oil. And this, if we didn't have this phrase here, is a function of, then we could have thought of the number of minutes being independent and depth depending on the number of minutes it's being filled. So this phrase, though, does give us more information than we really need, because it says the depth is, which means equals. So we have depth equals, and then it says is a function of the number of minutes. So some sort of constant, so I'll use k again for my constant, and the number of minutes, so times by minutes. So what that tells me is that the depth represents my y value, and the minutes represents my x value, and then I again have some sort of slope like k for that value. So let's go ahead and try to set up an equation here. So now we know that we've got time and depth. So this is our x value, because this is our independent event, and the depth is our y value because it depends on the amount of time we are actually filling the tank. So we've got more information than we need. So what I typically do is cross off one of the points and then find the slope. So remember our slope, m, or in this case k I'm using before, I'm going to take my y values, these two numbers, the depth of oil. So 3 minus 5. Then I got to start with the 0 since I started with the 3, so 0 minus 10. And this all equals, and then we can go ahead and do that subtraction. We got negative 2 over negative 10. So that will reduce down to 1/5. So that's our slope. So we take one of the points. This would be the easier of the points to use right here. And we put that into our point slope formula. So just as we did on the last part where we had 2 points, well, here we just have one extra, which we just don't need, so we just use 2 of the points to find the slope, then 1 of the points and the slope to write the equation. So we can go ahead and do that substitution. Remember, you're putting the values, like the 3 here, in for y1, then the slope is 1/5, and then we have x minus our x value, which is 0, so that goes in for x1. So when we use the distributive property and multiply it, we end up canceling out the constant. 1/5 times 0 makes 0, so what we're left with is y minus 3 equals 1/5 x. So you just have one final step there, and that's just to get that x by itself. So you do that by just doing one, or the y by itself. So you do that by doing this one step. You just add 3 to both sides. So our equation would be this. We would have y equals, and then it would be 1/5 x, and then we would have our plus 3. So what this means is that our y values, our depth of oil, equals the constant change, which is our slope, 1/5, times the number of minutes plus 3. And the reason it's plus 3 is because that's the depth we started at. So this is our starting point. So the next question is this: find the depth after 1/2 hour. Well, we got to be careful here. This, it says, the time was in minutes. So we've got to change this 1/2 hours to 30 minutes. So 30 minutes is what we need to use. And so that was the tricky part about this one. So we're going to substitute that 30 minutes in for x. Well, I'll go ahead and this is part of the answer. You're going to put this in the answer box and then do the substitution for the next part. So what we have is y equals 1/5 times by, and then 30 plus 3. So how far are we going to be down? Well, we've got to do some work here. 1/5 of 30, you're just reducing that fraction. So you see how 5 goes into that 30 6 times. So 6 times 1 makes 6. So we've got 6 plus 3, and that would give us 9. So y equals 9 feet is how far down we would go after that 1/2 hour. Well, let's take a look at the next problem. We've got a similar type of problem, and notice the wording here. When we look at this, the temperature of boiling water is tells us something. Is means equals. Is a function of altitude. Okay, well, that tells us right now that temperature is our dependent event. So it's going to be temperature equals, and then we're going to is a function of altitude. So we're going to have some sort of constant. This time I'll use m for slope, and then the altitude times by some sort of altitude. And we might have, maybe, we might have some sort of constant like c, some sort of extra number like a starting point, like we did on that last problem, like we had 3 feet. It was already 3 feet down before we started. And so let's take a look at our problem. Again, we want to find the slope. That's what we need to find first. So what this information tells us is that the temperature equals the y value. That is our independent event, and the altitude is our x value. So that helps us figure out how we should write the equation for the slope. So we need to take out one of these points. That bigger number seems like it's the one to take out, so I'll do that, and then I'll go ahead and substitute these values in. So my slope formula is the difference of the y values. So 210 minus 209. And then down below I start with 1,000, since that is my value that goes along with the 210, and then I do minus 1,500. I got to be careful here because you got to watch the signs. First number is positive 1, but the second number down below is negative 500. So I typically write it with the negative sign on top of the fraction. It doesn't matter where you put it, and some people even put it right in line with that fraction bar, just like that. And either way, it all means the same thing. Well, that's only half the problem. We still need to write the equation, so we need to pick one of those 2 points. We could even pick the one we never used. It doesn't really matter. All these points are going to be on the same line. So I'll just go ahead and take this one right here. It seems like a good one to use. So I'm going to write temperature of 210 in place of y1. And equals the slope. Okay, here's my slope, so it's negative 1 over 500 times by, now I got to use this number here, x minus 1,000. So now I go ahead and use that distributive property. And in this case, I end up having to multiply 1 over 500 by 1,000 and get a different number here. So let's see, we've got y minus 210 equals negative 1 over 500x, and it's going to be a plus sign because watch the signs. Negative times a negative makes a positive. Off to the side I might show that work here. Times by 1,000 over 1. So you can see the cross canceling that will end up occurring here. We can go 500 into 1,000 goes 2 times. And again, the signs canceled out, so that's why 2 is the number there. Well, we're not done yet. Still got to move this 210 back over, get y by itself. So I'll add 210 to both sides, and we end up with our equation in that slope-intercept form. And so we'll start with our y. Remember, that represents temperature equals negative 1 over 500 x plus, got to add because they're the same sign, 212. Well, 212 happens to be the boiling point of water at sea level, so that's our starting point. That's why that's our constant. The negative 1 over 500 means that for every degree, every 500 feet you go up in elevation, you're going to end up taking off the temperature is going to end up decreasing when it's boiling. So we've got our equation. We can go ahead and put that in the answer box. But now they wanted us to figure out, well, what happens when we are 6,000 feet up? Well, what we're going to end up having to do is substitute. So let's just rewrite our equation over here. We've got y equals negative 1 over 500 x plus 212. So we're going to take this 6,000, put that in place of, well, it's altitude, 6,000 feet. And that's an input that goes here. It's the independent event because it doesn't depend on anything, but the temperature of the water does depend on the altitude. So that's why we have that last, or that's why y is by itself here. So negative 1 over 500 times by 6,000, I'll put it all over 1, plus 212. So we go ahead and do some cross-canceling here. And we'll see that these two zeros will knock off these two zeros. So it's really just 5 into 60. Now if you knew your 12s, 5 goes into 60 12 times. So what's left over? Well, we've still got our y equals, and now it's going to be 12 plus, actually negative 12 plus 212. Now why is it negative? Because we only have one negative. This is a positive number, so one negative makes a negative. And when we do that subtraction, we're left with 200. So 200 degrees Fahrenheit is the answer for this one. Y represents temperature. So the key on these problems is to look at those key bits of information. Temperature of boiling water is means equals. So temperature equals, and now it's a function of altitude. So that means function means that we're going to end up having an equation where inputs always give the same output each time. And so since the temperature is a function of altitude, the altitude is the independent event, and the temperature depends on altitude. So those are a couple examples, and you'll have some to try in tonight's homework.